Today we are beginning our excellent adventure into statistics. Statistics is the collection, organization, analysis, interpretation, and presentation of numerical facts, also known as data. Today we are going to discuss two very important pieces of your statistics project, both collecting and organizing. Data is numerical information collected in a survey or in an experiment. You can classify data in two ways. You can classify it as qualitative or as quantitative. If you look at the first four letters of each of those words, you will be able to recognize the difference between both of those meanings. Qualitative, beginning with Q-U-A-L, measures the quality or characteristics. This feedback can be based upon opinion. For example, if you did a survey asking everyone what is their favorite color, your feedback would be names of colors. Quantitative, Q-U-A-N for quantity, measures a value and it's based on numbers. For instance, if you ask someone how many times a day they brush their teeth, their feedback would be numerical data. We will now discuss an example of qualitative versus quantitative data utilizing our Starbucks latte. First off, we could describe what we're smelling. This would be qualitative data. Another piece of qualitative data may be its appearance. It's a nice frothy appearance, the wonderful whipped cream on top of our Starbucks latte. We could also describe the taste as being strong, possibly bitter. And we could also describe its appearance with a white cup, and you could also include the green logo if you'd like. Now, when we're thinking numerically, we could discuss the 12 ounces of latte that this cup contains. We could think about its serving temperature of 150 degrees. We could also consider the height of the cup at 7 inches, or its cost for a measly $4.95. Can you think of anything else that you would like to include? When doing your study and collecting your data for your statistics project, there are many things to be considered. First off, you want to ensure that your data is a fair representation of the census. For your statistics project, we'll be using the Algebra R students as our census, or the entire population. You are going to need to devise a sample, or something that is a representative portion of a population. Due to the difficulty in asking every single person a question, or having every single person sample something or try out a new product, most statistics use samples versus asking the entire population of the United States to try the new Red Bull flavor. Bias are samples that favor some portion of the population. When you are discovering what sample you're going to use when you're doing your survey for your project, you want to assure that it is unbiased. For example, if you asked every single person that walked into the library a question about how many hours they study, your findings may be different than when you ask every single person in the cafeteria a question on how many hours they study, being that usually students that go to the library are there to study, and all students, or the majority of students, go to the cafeteria for lunch. Experimental design. Experiments need more than one group to test their hypotheses. When you are discovering how a drug impacts the human being, you may use a control group. This group does not receive any treatment. They're left alone in their natural condition. You will compare this to a treatment group. This group is the one that gets the treatment or receives the drug. They're experimented upon to measure the effects of the treatment. There's also something called a placebo group. Sometimes if people take a drug, they may think mentally that it is improving their health. If you give a placebo group, you can study this psychological impact A placebo is a false treatment used to measure differences in other groups. So if you give someone a Jolly Rancher and tell them that it is going to cure all their pains and ailments, they may believe you and say, oh, I am healed, whereas they've only taken a Jolly Rancher, versus giving someone else the actual drug that you had created and wanted to test to see the actual. Sometimes you will do a blind. You won't let people know which group they're in so you can avoid biases. A single blind means that only the subjects don't know, the people being tested, and a double blind means that neither the subject nor the experimenters. When data is not organized, it's hard to make sense of it. So using a table is a great way to organize your data. This is something that you guys will be doing when you are going to be presenting your statistics project. Sometimes the data lends itself to individual treatment, so you will have to decide based on the information that you collect how you want to organize it. Either the numbers are close together, or each number individually is going to matter. For example, the number of absences a student has. We've collected this list of data, and we are going to record it in something that we call a frequency table. Because it's not easy to just count all of the numbers as we go through, we're going to keep a tally. We're going to come across the number 0 as our first order of data. So we're going to cross that off and put a tally mark in the 0 box. Next is 3. We're going to put a tally mark in the 3 box. So what we're doing is we are keeping a count of how many of each of those number of absences occur in our total frequency table. So as you cross numbers off, you can record where they are. And we're going to continue to do this. Every time you cross off a number, you put a tally in the box that corresponds with it. So now we're going to count our tally marks and record that in the frequency, or how often the 7 occurs. We have 1 7. We have no tally marks here, so we're going to put a 0. We have 1 tally mark in the 5 box, so we're going to record that with a 1. We have 2 tally marks in the 4 box, so we're going to record that with a 2. We have 3 3s, 3 2s. Now if you look here, we have 5 tally marks. We cross the 5th one, plus 1, which is going to give us 6 for 1 absence, and we have 9 0 absences. So our total frequency is the total or the sum of all of the frequencies that we've acquired. This number should match the number of pieces of data that you want recorded. So if you counted all of these numbers, you should get 25. If you add all of these numbers, you should get 25. If those numbers do not match, you may have missed a piece of data, so you're going to need to go back and check. When data is not organized, it's hard to make sense of it. So using a table is a great way to do that. Now sometimes the data lends itself to grouping. In order to do grouping, you're going to have to establish intervals to place the data into these groups. Rules for grouping data. The first thing you want to do is cover the complete range of data. So you want to include the largest value as well as the smallest value. To find the range of data, you subtract the lowest value from the largest value. Intervals are equal in size. So if you have data, you need to make sure that every single interval has the same amount of values in between them. So 70 to 75, 76 to 79. You're going to have to decide if those have the same amounts of data. which they do not, so you're going to have to keep that in mind when establishing your intervals. Intervals can't overlap. For example, if you establish intervals 70 to 80, 80 to 90, the 80s would overlap between those two intervals. So here we have a class's test scores. We've established intervals of the same exact size in order to record our information. If we made every single value a value in our table would be quite large. So we grouped values together in order to establish our table and make it more aesthetically pleasing and easily legible. So first we have a 90, which will work into the 81 to 90 group. And we're going to record all of our tally marks the same way that we did in the last table. The only difference is now it's not individualized scores, it's intervals based upon the data that we've collected. Please make sure that you are trying this on your own. And then you can count up your tally marks and include that value in your frequency box. Again, your total frequency should add up to the amount of test scores that you have in your original data. You can create something called stem and leaf plots with quantitative data. If you have this group of values, you can examine the data and find both the lowest and the highest values. The lowest is a 1, and the highest is a 58. What is our highest place value? It's going to be the tens place. This is the ones place, this is the tens place. We only have 2-digit numbers, so the highest place value is going to be the tens place. This place value, the highest place value that you see, become the stems of our stem leaf plot. The remaining place values are our leaves. So in order to set up a stem leaf plot, we're going to have to set up our stems. We have numbers ranging from 1, which has a 0 in the tens place, to 5. These are our stems. Now we're going to record our data. If you look at the first number, you have 45. So 4 is your stem and 5 would be your leaf. So you would record a 5 in your leaf column. 1 has a 0 in the tens place and a 1 in the ones place. 52 has a 2 in the ones place, so that is going to be your leaf. We're going to continue recording all of our data. Go ahead and try this on your own. And all we're doing is putting our ones place in the leaf column next to its stem, which is the value that's in the tens place. Now, we need to also have a key so someone knows how to read our chart. 4/5 is equal to 45. So we know how to read this number. In addition, right now our leaves are not ordered. We are going to need to put them in numerical order. Your final product of a stem leaf plot is going to be ordered leaves with proper stems. Notice the values from 0 to 9 are included in this interval here. The values from 10 to 19 are included in this interval. Values of 20 to 29 are included here. 30 to 39, 40 to 49, and 50 to 59.